There are more than 275,000 glaciers located in mountain ranges, from the tropics to the polar regions. Glaciers are highly sensitive to climate change, and their melting clearly illustrates the impact of ongoing atmospheric and oceanic warming. Loss of glacier ice causes global sea level to rise, depletes regional freshwater resources, and increases the risk of local hazards. Monitoring glaciers is important for understanding the impact of climate change and accurately projecting future freshwater resources and sea level rise. Traditional methods of monitoring glacier changes on the ground are restricted to a few hundred glaciers worldwide, but global monitoring of glaciers is now possible using satellite observations. There are several techniques available, each with their own strengths and limitations. Stereo imaging and radar interferometry produce detailed digital elevation models. Repeat mapping, typically 5 to 10 years apart, allows changes in elevation to be measured. Radar and laser altimeters measure the elevation of a glacier's surface with great vertical precision, but require extrapolation to cover a full glacier. This can be done at monthly or annual time intervals, but there are gaps between satellite footprints and ground tracks. Satellites measuring Earth's gravity field can directly measure changes in ice mass, but at a very coarse, spatial scale. It is also a challenge to separate the glacier signal from other hydrological components. In a community effort, the Glacier Mass Balance Intercomparison Exercise, GLAMBI, compiled all major studies using these different techniques to give an estimate of the world's glacier mass changes over the last 2 decades. In total, the world has lost 5% of its glacier ice since the year 2000. But in some regions, almost 40% of the ice has gone. Ice melting from glaciers caused sea level to rise by 18 millimeters between 2000 and 2023. This is expected to increase to 32 to 67 millimeters by 2040. The world is currently losing 273 gigatons of glacier ice each year. That's about the daily water intake of every person on Earth for 30 years. The GLAMBI project provides a new glacier observation baseline, allowing improved projections of freshwater resources and sea level rise.